Okay, hi. My name is Jacek. I'm from Trinity College Dublin. I'm working on with Professor Luis da Silva. What we are looking at is various models of mobile network sharing. In this work that we have here, we are presenting here, we are looking at stochastic geometry models of mobile resource sharing. In particular, we are applying some very specific form of coordination to allow different levels of resource sharing between mobile network operators. So the motivation is really related to the costs that mobile network operators are facing, and this motivates them to share the resources. Those resources can be infrastructure, which in our case means that the transmitters of a single operator can be utilized by users of different operators, or spectrum, which means that the transmitters of different operators will utilize same same license bands. So we can translate this deployments of different operators into a stochastic model of allocations of transmitters and apply different types of policies to spectrum and the infrastructure. The policies that we are using are based on the idea of exclusion zones. So depending on the willingness of operators or the regulatory framework that there may be, the operators create exclusion zones around the transmitters where their resources may be shared, or well, outside of which their resources will be or may be shared. Now, for what we do in our work is that we look at the distributions of networks of different operators, and for essentially for any processes other than the Poisson point process, the closed form of the interference is really intractable. So therefore, what we want to set up a model for Poisson point process, where each network is distributed accordingly, and then they are superimposed, and then they are independent of each other. So what that allows us to obtain closed form expressions for the complementary cumulative distribution function of SINR. Of course, this itself allows us for some level of insight into how the operators can possibly share networks. But this also allows us to validate any kind of simulations that we want to make with other point processes. In an essence, point processes that allow for certain level of correlation between the transmitters of different operators. And specifically, we use Gauss-Poisson point process to model also clustering between networks of different operators. And these are the results here that we observe here. So just to quickly summarize, what we do in our work is we provide a model that allows mobile operators or regulators to essentially assess the performance of different forms of resource sharing. In this case, it's spectrum and infrastructure. And what we also observe, actually, when we start looking into those results, then there are some interesting trade-offs between spectrum and infrastructure sharing, and that it's actually also this relative distribution of the networks of two operators will have an impact on the efficiency of this sharing. Thank you.